Okay, guys, I need to explain something here because it's really kind of confusing, and that is why hypercalcemia causes decreased neuromuscular excitability. Because if you think about this, it's not really the way you would think it would work. So, say we go back to our basic, action potential, right? And you have your negative charge. I don't know, negative 90 microvolts, or whatever you're talking about, right? And the action potential, as you know, kind of goes up with sodium, and then you have like a threshold due to calcium, and then it kind of goes down because of potassium, right? Well, if you take that and your resting membrane potential is way down there, and this is like your all or nothing spot right here, okay? We already know if we're looking at a cell, okay, you look at the cell, that negative, what it means is that inner membrane of the cell is negatively charged, okay? So we already know, again, with the typical action potential, if you have sodium outside your cell, then as it rushes in and brings its positive charges with it into that cell, it's going to affect that depolarization of the action potential, causing it to depolarize and become more positive, and that's the first part of depolarization. We also know that calcium happens to be the ion for the plateau in the action potential, and we know that potassium is responsible for the downstroke or the repolarization and hyperpolarization of that action potential. So if you think about that, potassium of course has a positive, but it started out inside the cell, and when it rushes out of the cell, it takes its positives with it, and therefore it completely changes it over. So again, when sodium comes into the cell with its positives, it's going to turn that membrane positive, right? And then when potassium takes its positives and leaves, it's going to turn everything back to negatives. Okay, so that's basic physiology. We know that. Okay, well, here's the thing, is when we start looking at that and we say, well, how does calcium affect this whole thing? And how does hypercalcemia, of all things, cause a decreased neuromuscular excitability? Especially, it's confusing if you're talking about the fact that calcium, of course, has positive charges, right? Well, you would think if calcium is taking its positive charges because you have too much in your blood, therefore, it would try to equalize back out into your cell, and you'd think that would take it where it increases pulls you closer to your threshold, right? So you would think that calcium, adding that into the mix, would go ahead and take you closer to your threshold, and you would think that would be like, well, I don't have very far to go before I'm all or nothing, right? And that would increase excitability. But again, notice here's what happens in reality, is it is decreased neuromuscular excitability. And that is because of one factor, okay? And that is that increased calcium in your bloodstream actually will interfere with those voltage-gated sodium channels, and that's the key right there. It interferes with the sodium channels, therefore sodium doesn't do that as easily and cause a depolarization, and therefore none of that action potential really happens, and that's why hypercalcemia actually causes a decreased neuromuscular excitability.